Welcome back. That last project was a little bit overwhelming because we used a ton of libraries and a lot of data visualizations that are very specific to a library. But we haven't really touched the topic of training the data and creating models. So in this project, we're actually going to do some machine learning. It's going to be a lot of fun. But I want to give you a warning. This is just a taste of what machine learning is like. If this is your first time, it might seem a little bit overwhelming. But just like with anything, it's all about practice and repetition. But hopefully, by the end of it, you will see the 6-step process and how it actually works. And at the end of the day, you'll also realize that it's not maybe as complicated as you might have initially thought. So let's get started. The first thing we're going to do is create a new notebook with Python 3. Now, this time around, we're going to use a different data set, and a famous one when it comes to machine learning. It's called the iris dataset for the iris flower. So if I type in iris flower, it's a dataset that has all this information about the iris flower that actually has different types. So we're going to create a machine learning model that can detect types of the iris plant. Now, luckily for us, we can access this data very, very easily using scikit-learn. Scikit-learn, if you remember, was another library that is really, really powerful to help us with machine learning. So all we have to do is say from scikit-learn dot datasets, and scikit-learn comes pre-built with some good datasets that you can explore on your own. And we're just going to import the iris dataset, or lowercase I, just like this. So that if I do iris equals load.iris, just like this, and I click run, and this should be an underscore. So we now have the data loaded. And if we go back to our REPL, we've imported the data. We don't need to clean the data. We learned about that in the previous project. But because scikit-learn has these data sets pre-built, we can assume that it's clean data that we can use in our models. The next step is to split the data into training set and test set. But in order for us to do that, we can use this concept of X and Y in machine learning. So X, this capital X, usually means the inputs that we want to give to our machine learning model. So in our case, we'll say iris.data will be our inputs. So that is the data that we get. So let's actually see what that is. Let's run. That's the data. You see that it's just some massive arrays. And Y is going to be the target. So if I do .target and I click run, you'll see that this is the target. Now, what this means is we want to find or create a function that takes in X, which will be our data, and outputs the Y, which is the target, that is the answer. Now, in our case, these are the answers, 0, 1, and 2. But if I Google iris dataset, and I go to the Wikipedia page here, you'll see that there are 3 types of iris: the setosa, versicolor, and virginica. And each one of these is represented by either 0, 1, or 2. So if we look at our data set, this target is the types of those 3 iris flower types. So the target in this case that comes pre-set with the scikit-learn library is this is the data of the images. So again, if I remove this and hit run, this is the image. So each list is a piece of data that represents by some parameters the iris flower. And then we have the target, which is the answer, is when we input this data, what is the output? Which one of the 3 flowers is it? Now, if I go to Kaggle and I actually type in the iris dataset, you can see that the columns are, well, the length of the petal, the sepal length, and then the species name. So you can see here that these are the columns that it's testing for. And you can see these are the numbers that we get in that array, and each one corresponds with different type of the iris flower. So let's get back to that. I'm going to say that capital X is going to be our data, our input. And then Y, lowercase y, and this is just a standard, will be our target. Finally, we actually want to get the feature name, so each item in the list here is a feature. Remember, that's what these columns are. These columns are the width, the length of the petal, and the sepal. So we can store that by simply saying feature names as the iris dot feature names, again, which comes pre-built with the iris dataset. And then the target names will be the iris dot target names. Again, if I run this, let's do feature names first. There's the columns. And if I do target names, you see that these are the 3 options. So up until now, we've imported the data. We didn't have to clean the data. We haven't really split the data yet, but we're at least starting to understand our data and perhaps what it contains. So once we've understood the data, and knowing that we have this information, we can now start splitting the data into a training and data set. Because right now we're doing supervised learning because these are labeled, right? We have all the data that we need, and we also have the answers that we need so we can test our model. By the way, before I show you how to split the data, what do you think the type of X is? Can you guess? It's a NumPy array. Remember that library NumPy that I told you allows us to use multi-dimensional arrays? Well, underneath the hood, this dataset is a NumPy array. It's a little bit more feature-rich than just a Python list. Anyway, let's start to split our data. So what we want to do here is from the scikit-learn library, I want to grab the model selection. And in here, we're going to import the train test split. Now, what is that? Let's Google and find out. So again, if I go to the library documentation, you can see that the train test split simply splits array or matrices into random train and test subsets. So it just randomly decides for us how it's going to split the data into the training data and the test data. So now we can use it in an interesting way. We can simply say X is the training dataset, the X test dataset, the Y train dataset, and then the Y test dataset. And again, we can just assign that to variables by using the train test split function that we import and give it the x, the y, and some different variables. So for example, over here, if you can see, we have things like test size or random state or shuffle, different variables that we want. Again, you can read this on your own. In our case, let's just say that the test size will be 0.4. Now, let's have a look at what kind of data we have now. So if I do print x, the train data, and we can do dot shape here, and we'll also print the test shape. If I run this, it returns what we call a dimensionality of the array. So that is how many rows and columns. So it's got 4 columns and 90 rows. So our train data has 90 rows and our test data has 60 rows. If I change the test size here to 0.5 and I click run, you see that now I'm splitting the test size between 50% being for train, 50% for test. So we can actually change things up and try different things and manipulate the train and test data size. Ideally, though, we want to have more train data than tests, just because remember, the more data we have, the better our model is going to get. And this is going to be the same for the yTrain and the yTest variables as well. Congratulations, we've just split the data into training set and test set. We now have some exciting steps ahead, such as creating the model. Let's take a break and learn how to do that in the next video.